All right, guys. So what we're doing today is we are finishing up the note sheet from yesterday.
Okay, do it right. No, didn't do it right. What did I do wrong?
Because you have to simplify what's inside each of those absolute values first and then simplify the whole thing. So I believe this is the problem we stopped off on yesterday. Square root method. Now, yesterday we went over solving quadratic equations by graphing. So we would graph it and see where it crossed the x-axis, because the points on which it crossed the x-axis were the solutions. We were looking for what values of x will make the function equal 0, what values of x will make the y value be 0 with graphing. The next thing we went over was solving by the square root method. Now, the square root method works if the only variable that we have is either being squared or inside a set of parentheses that's being squared. And if we have that, the first thing we're going to do is get the squared term by itself is the first main step. So if we look at this problem here, we have 3x squared minus 9. So the term being squared is going to be x squared. So we need to get it by itself first. Now the first thing we can do in getting it by itself is to add 9 to both sides. Because our negative 9 plus 9 will simplify to 0, leaving us with 3x squared on the left-hand side. On the right-hand side, 0 plus 9 is going to be 9. Now our squared term is not by itself, because we still have that 3x squared. We need to simplify the 3 out of the left-hand side. So what we can do is divide both sides by 3. 3x squared divided by 3 is going to be x squared. 9 divided by 3 is 3. Once we get the squared term by itself, we're going to take the square root of both sides. And really, we could call this also the nth root. There is a way that we can do this with higher powers. But for now, we're just going to take the square root of both sides, and then the last step is going to be to solve for the variable. So at this point here, we're going to take the square root of both sides. Now the square root of x squared is x. Now we do need to find the square root of 3. Well, the square root of 3 is just the square root of 3. Because when we look at square roots, we're trying to see what times itself gives us the number inside. And there is no nice number, no integer, no whole number that multiplies by itself that gives us 3. Now, one thing we do have to be careful with is whenever we take the square root of both sides, we do have to add the plus or minus. Because when we square a number, we multiply it by itself. A positive times a positive is still positive, and a negative times a negative is a positive. So we have positive or negative square root of 3 is the solution for this here. Now, since x is indeed by itself, this is it. X is equal to plus or minus the square root of 3. Now, if we tried to graph this, we wouldn't get a nice number because the square root of 3 is an irrational number. It's a non-repeating, non-terminating number. It has a decimal that goes on forever. So graphing it, we won't be able to just find it. We can get approximations, we can get close, but we can never actually nail it down because the decimal does not end. So here, using the square root method, using other methods besides graphing, is going to give us a better answer, especially just using the graphing calculator. Questions on this here? Let's look at the next one here. We have 2/5 times x plus 3 squared equals 5. Now, when we look at this here, the only variable that shows up is inside those parentheses being squared. So we can still use the square root method. Now, if it had told us that we had 5x outside the parentheses, that would not work. We have to have the variable only inside the parentheses being squared, or x, or the variable is the only term being squared. We don't have x to the first, we don't have x to the third, it's just x squared, or the variables inside those parentheses being squared. Now our steps are still going to be the same. We need to get that squared term by itself. So we're trying to get the x plus 3 squared, that whole term by itself first. And the only thing really with it is the 2/5. Now, since our x plus 3 squared and the 2/5 are being multiplied, we're going to undo that by dividing. We could also have multiplied both sides by 5/2. Either way works, because 2/5 divided by 2/5 reduces to 1, telling us that x plus 3 squared is equal to, well, we're going to have to divide 5 by 2/5. So we can say 5 divided by 2/5 is 25/2. Or I could have said 5 over 2/5 is still 25/2, 25 over 2. Questions on this so far? Now the question is the term being squared by itself. Because we have that x plus 3, yes? Is that a part of our term being squared? Well, yeah, that whole thing, the x plus 3 is the part being squared, yes? So we're trying to get that set of parentheses by itself. It doesn't matter that there's x plus 3 inside, we just want that whole term by itself. Since there's nothing being added to that set of parentheses, there's nothing being multiplied or divided by that set of parentheses, we've got it by itself. We're not so much concerned of what's inside the parentheses, more that the parentheses are by themselves. So here they are. And because this term is by itself, we can take the square root of it. Because our square root and square will cancel, leaving us with x plus 3. But we take the square root of one side, we've got to take the square root of the other. So we do have to take the square root of 25/2. And really what we're looking at is what times itself is 25, and then what times itself is 2. So if we did this off to the side, kind of simplifying it out, we're really looking at the square root of 25 over the square root of 2. Now the square root of 25 is nice, it's just 5 over the square root of 2. Now we can't leave it as this here, we do have to do some simplifying. And to simplify here, we would multiply the top and bottom by the square root of 2 over the square root of 2, because really all we're doing is multiplying it by 1, because anything divided by itself is 1. On top, it's nice. 5 times the square root of 2 is 5 square roots of 2. On bottom, the square root of 2 times the square root of 2, well, 2 times 2 is 4, and the square root of 4 is 2. Now, if we type this into the 30xs or the graphing calculator for sure, it's always going to give us a decimal approximation. It gives us this here. Now, we can do it in the 30xs. The only thing we have to make sure to do is to split that fraction apart. If we split it apart and take the square root of 25 divided by the square root of 2, 25, square root of 25 over the square root of 2, it will actually simplify it for us. 2, 5 square roots of 2 over 2. So it's not too bad to do it by hand. 30xs will do it for us. But we get this here. Questions on this so far? Questions on anything we've done so far? I think the main tricky part of this here so far was just simplifying the radical. So we've completed steps 1 and 2. Is the variable by itself? Well, no, we have x plus 3 equals plus or minus 5 squared to 2. So the last thing we have to do is to get x by itself. And the only thing we have to move here is the plus 3. So we would subtract 3 from both sides, giving us x by itself. When we add or subtract a number, when we have that plus or minus on one side, we put the number that we add or subtract in front of it. So we would say negative 3 plus or minus 5 square roots of 2 over 2. And this is it, because 5 square roots of 2 over 2 and negative 3 are not like terms. If it was negative 3 square roots of 2, yes, we can combine, we can add and subtract, but because they both don't have the same radical, they are not like terms. This is as simplified as it gets. If we are able to add or subtract, we need to add or subtract the two together. And what I mean by that is this. If we got into the end and it said 3 plus or minus 5 halves, we didn't have that square root of 2. These are like terms. We can say that x, take negative 3 plus 5 halves. And we can actually find negative 3 minus 5 halves. We can actually combine these. If we can combine these like terms, we need to simplify. We need to combine them. This negative 3 plus 5 halves is going to be negative a half. And negative 3 minus 5 halves is negative 11 halves. Because if we can add or subtract, we need to add or subtract. Here, not like terms, we can't add or subtract, so our final answer is the negative 3 plus or minus 5 squared to 2 over 2. That is the final answer. Questions on this here? Look at the next one. 2/3 x squared plus 14 equals 20. Since the only variable we have is the x squared, we don't have x to the first, we can use the square root method. So the first thing we're going to do with this square root method is get our x squared, our term being squared by itself. So the first thing I would do is want to move the 14 over. Since we have plus 14, we would subtract it from both sides. So our 14 minus 14 is indeed 0, telling us that 2/3 x squared is equal to 6, because our 20 minus 14 is 6. Our term being squared is still not by itself. We have 2/3 x squared. So to simplify the 2/3, we would divide both sides by 2/3. Because our 2/3 divided by 2/3, anything divided by itself is 1, giving us x squared. On our other side, we have 6 divided by 2/3. We can do it by hand. We can do it in a calculator either way. And 6 divided by 2/3 is 9. Now we do have the squared term by itself, which means we can take the square root of both sides. And our square root of x squared is going to be x is equal to plus or minus square root of 9 is 3. So it's telling us x is equal to plus or minus 3. Not every single one of the answers we get from the square root method will have radicals or be these not nice numbers. They can, not always. But if we do get nice integer answers, it means that the function itself, the equation we started with, was factorable and graphable. Any questions on these so far? Negative 2x squared plus 1 equals negative 6. So again, we can solve this by the square root method because our variable, the only variable we have is x squared. We don't have x to the first. So the first thing we're going to want to do is get the x squared by itself. And we can do that by subtracting 1 from both sides. Now, on the left-hand side, our 1 and -1 will simplify, leaving us with negative 2x squared. Negative 6 minus 1 is going to be negative 7. At this point here, we still need to get the x squared by itself, so we're going to divide both sides by negative 2. Negative 2x squared divided by negative 2 is going to be x squared. Negative 7 divided by negative 2, well, 7 does not divide by 2 evenly, but our negative and negative will make a positive. Now that we do have the squared term by itself, we can take the square root of both sides. Now the square root of x squared is going to be x. X is equal to plus or minus. Anytime we take the square root of both sides, we have to add the plus or minus. Now the square root of 7/2. Especially if we're simplifying, it's going to be nice to use the 30xs, that yellow calculator, take some simple calculations out of the equation. We do have to split it up. We can take the square root of 7 over the square root of 2 and get the square root of 14 over 2. Now at this point here, we finished with steps 1 and 2. We need to solve for the variable. Is x by itself? Yeah. So that means we are done. So this here, x is equal to plus or minus square root of 14 over 2. X is equal to square root of 14 over 2, and x is equal to negative square root of 14 over 2. We just use the plus or minus to be able to write both equations in one simple form. Questions on this here? Let's look at one last one of these here, but this time with a set of parentheses. And again, the reason we can use the square root method on this is because the only spot the variable shows up is in that term being squared, that x minus 4 being squared. We don't have it any other variable outside the parentheses. So we have 2 times x minus 4 squared is equal to negative 5. So the first thing we want to do is get the term being squared by itself. So we're going to divide both sides by 2, telling us that x minus 4 squared is equal to negative 5 halves. At this point here, we're going to square root both sides. On the left-hand side, the square root and square would cancel, telling us x minus 4 is equal to plus or minus. So we can break this up to simplify it. We can say the square root of negative 5 over the square root of 2. Is domain error. Because what did we say? Anytime we multiply a number by itself, it's going to be a positive number. There is no number. There is no real number when we multiply it by itself that gives us a negative. So it is not possible to find a real number when multiplied by itself that gives us negative 5 halves. So really this here is no real solution. So we are going to start learning and going over how to find these. There are numbers that we can use to get us to the square root of negative 5 halves. We just haven't covered them yet. Because if we look back at this here, I'm going to add 5 to both sides. And the reason I'm doing that is I'm wanting to get it equal to 0 so I can graph it. So we can see the graph of this here. So if I look at the graph of it, 2 parentheses x minus 4 squared plus 5. is this graph here. It does not cross the x-axis, so there are no real solutions that work for it. But after 3.4, we're going to actually be able to find the solutions. We're going to be able to find the values of x that will make that true. Now, the only other thing we're going to do here with solving is solve by factoring. We've done this already. We've solved by factoring before. So we're going to do a few with solving for factoring, and we're done with 3.3. Now, when we solve by factoring, the first thing we have to do is get the equation equal to 0. So with our x squared minus 4x equals 45, the first thing we want to do is get this equation equal to 0. Now, when solving quadratics and most higher degree polynomial functions, getting the equation equal to 0 is always a great first step. Square root method, and we will eventually come to it, completing the square, are really the only two main ways that we solve where the equation is not going to be equal to 0 to start with. Now, with factoring, we need it equal to 0, so we get x squared minus 4x minus 45 is equal to 0. Now we can start factoring the left-hand side, that x squared side. Now we look for greatest common factor. There is not a greatest common factor between x squared, 4x, and 45. So we'll move on to our two sets of parentheses with 3 spaces. Our second step is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, since the third term is indeed negative, our signs are going to be opposite. One's going to be positive and one's going to be negative. Now we need to find the factors of the first and third terms. Now the factors of the first term, factors of x squared, the only set of factors for it are x and x. Only factors that we have for x squared. Now the factors of 45, on the other hand, there's a few of them, because we have 1 and 45. 2 is not a factor, but we have 3 and 15. 4 is not a factor, but 5 is, 5 and 9. The next number after 5 would be 6. 6 is not a factor because 2 and 3 both have to be factors for 6 to work. 7 is not a factor, and 8 is not a factor. So we found them all, because the next one would be 9. We already have it listed. So now we need to pick between these 3 here. What do we want to try first? 3 and 15. Last thing we want to do is multiply together to get our middle term and see if it matches up. X times negative 15 is going to be negative 15x. 3 times x is going to be plus 3x. And negative 15x plus 3x is going to be negative 12x. Fortunately, that's not the middle term we wanted. Now we could flip the 3 and 15, multiply again. We would actually get positive 15x minus 3x equals 12x. So which set of factors do we want to try next? 5 and 9. And we can check it again. X times negative 9 is negative 9x. 5 times x is plus 5x. And negative 9x plus 5x would give us negative 4x. So that is the correct middle term that we wanted. And since we got it factored and we got to this point here, we do have two things multiplied together to equal 0. So one of these two is going to be 0. Either x plus 5 is 0 or x minus 9. Now we can solve for the value of x. So with our x plus 5, we can subtract 5 from both sides, telling us that x is negative 5. With our x minus 9, we can add 9 to both sides, telling us x is equal to 9. So for this here, x is equal to -5 and x is equal to 9. Questions on this one here? Are you ready for the next one? 3x squared minus 5x equals 2. Again, if we want to get this or solve it by factoring, the first thing we need to do is get this equation equal to 0. So we would subtract 2 from both sides, telling us that 3x squared minus 5x minus 2 is equal to 0. Once we get it equal to 0, we can start factoring the left-hand side. And the first thing we're going to look for is the greatest common factor between 3x squared, 5x, and 2. Now, there's not a number that goes into all three terms. So we'll have our two sets of parentheses with 3 spaces. Takes us through the first 2 main steps of factoring. Our third step is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Now, since our third term, 2, is negative, we're going to have plus and minus. One of them is going to be positive, one of them is going to be negative. At this point here, we need to find the factors of 3x squared. Well, x squared is just x and x. Our factors of 3 are 1 and 3. There's only one set, so we just need to stick 3 in one of the 2 spots. I normally just stick it in the first and go from there. Now we need to find the factors of the third term, which is just 1 and 2. Where do y'all want to put the 1? Where do you want to put the 2? Put 1 in the first, 2 in the second. Because again, at this point, I would focus more on just getting it set up, because once we check, it'll tell us if this is the correct setup. 3x times -2 be -6x. 1 times x is positive 1x. -6x plus x, -6 plus 1 would be -5x. Now that is the middle term that we wanted, so now we can start solving. Because the main reason we factored and got it to this point is because now I have 2 things, 2 expressions being multiplied together to equal 0. And the only way we can multiply 2 terms together and get 0 is if one of the 2 is 0. Now with our 3x plus 1, we can go about solving it first by subtracting 1. We subtract 1 from both sides, we get 3x equals -1. We would then divide both sides by 3, telling us x is equal to -1/3. With our x minus 2, first thing we can do is add 2 to both sides, telling us x is equal to 2. Any questions on this here? We're going to look at 2 more problems, and then we will be done for the day. And the first one is this here. Find the zeros of a quadratic function. So far we found the factors, we factored it and found solutions. When we graphed it, we found the x-intercepts. And what we've been doing with all of these here, we're trying to find the values of x that will make the function be what? 0. We're trying to find the values of x that will make the function be 0. So really, we're trying to find its zeros. Solutions, x-intercepts, zeros. all of these are the same way of saying the same thing, in that I want to know what value of x is going to make the function 2x squared minus 11x plus 12 be 0. That's all it's asking. The real solutions, the real zeros, the rational zeros. What values of x is going to make this function be 0? So we have 2x squared minus 11x plus 12. Now, if it doesn't specify, it says we can do any method. I could come over here and say 2x squared minus 11x plus 12 and tell it to graph. And we do have two solutions. We see it crosses the x-axis at 2 points. One of them looks nice, one of them looks like a fraction. We can go second table. And I do see that one of the solutions is 4, but I still have to find the other. Now that can help us get an idea and guess what this is going to be. But I'm going to go on and factor it. 2x squared minus 11x plus 12. Now we do already have it set equal to 0, so we're good there. Next thing we would look for is the greatest common factor between 2x squared, 11x, and 12. 2 is the factor between 2 and 12, but it's not 11, so there is no greatest common factor. Now we're going to find the signs. Since the third term is positive, the signs are the same and match the sign of the middle term, and the sign of our middle term is negative. So we'd have negative and negative. Now we want to find the factors of the first and third term. Well, our first term is 2x squared. So the nice thing with x squared is it's going to be x and x. Oh, factors of 2. There's only one set of factors for 2, which is 1 and 2, so we can just throw those in. Factors of 12. 1 and 12. 2 and 6. 3 and 4, and we're done. Those are all the factors of 12. Which one do we want to try first? 1 and 12, 2 and 6, 3 and 4. 3 and 4. We can plug them in, and again, we're trying to check and make sure we get the correct middle term. 2x times negative 4 is going to be negative 8x. Negative 3 times x is negative 3x. Negative 8x minus 3x, negative 8 minus 3 is indeed negative 11x. So those are our correct factors, yes? Now we have two expressions multiplied together to equal 0, so one of them has to be 0, yes? So either 2x minus 3 is 0 or x minus 4 is 0. But with our 2x minus 3, the first thing we'll have to do is add 3 to both sides, because our negative 3 plus 3 is 0. Telling us 2x is equal to 3. Divide both sides by 2. Telling us x is equal to 3/2. Our x minus 4. First thing we'd have to do is add 4 to both sides, telling us x is equal to 4. Well, we knew that one already by graphing, yes? So it kind of gives us a hint. It lets us know that, yes, these are the correct factors. One of them is going to be 4. The other is 3/2. Questions on this here? Now, this is kind of nice to know. Even if it asks for 0 solutions, it's still the same thing. You ready for the last one? We're going to look at 9 because I have a feeling at this point we've gotten a good handle on this here. Number 9, we want to find the 0 for this here. We want to find out what value of x is going to make x squared minus 8x be 0, yes? Now we could try graphing it. I'm going to go on and factor it. So when we solve by factoring, the first thing we need to do is get this equation equal to 0. Everything on one side, 0 on the other. Do we have that? Yes. First step in factoring is to see, is there a greatest common factor? Is there something in common with both terms? Is there something in common with 8x squared, or sorry, x squared and 8x? There actually is. Because up to this point, we've always had, say, 8x or x squared minus 8x plus a number, yes? X squared and 8x have something in common, x. There's nothing saying that we can't factor a variable out. Because I can take an x out of x squared, and if I factor an x out of x squared, we're left with x minus, if we factor an x out of negative 8x, we're left with negative 8. So we can factor that x out. We haven't up to this point because the variable hasn't been in common with all three terms. But here we can factor that x out. Now looking at this here, what's inside the parentheses is as simplified as it gets because the degree is 1. Do I have two things multiplied together to equal 0? Yeah, because we have x being multiplied with x minus 8. So here either the x is equal to 0 or x minus 8 is equal to 0. One of these two has to be true. We'll look at the x minus 8 first. To solve it, to get x by itself, we would add 8 to both sides, telling us x is equal to 8. Are you ready for the other equation? Well, the other one says what? X equals 0, yes? Is x by itself. So x is equal to 0 or x is equal to 8. I could graph it, we get something that looks like this here. Now we do see it crosses the x-axis at 2 points. If we look at the table, again, we're looking for what value of x will make the y value be 0, yes? Here, 0, 0. X is 0. Then the other value is when x is equal to 8. And that is it. That is all we're doing in 3.3.